In this section, I'm going to talk about local preference. Local preference is an attribute that is advertised to IBGP neighbors. So if I set a local preference on router 3, the route that has this local preference will have its attribute on router 1 and router 2. So these two routers will know that I have set a local preference value on router 3 and will apply that in their best path selection algorithm. So what I'm going to do in this example is this. On router 3, I receive a route for network 50 that is advertised in internet. I'm going to change the local preference on this. The default local preference is 100, but I'm going to change it to a higher value, for example 1000. Any value more than 100 will be good. So I'm going to use, for example, local preference of 1000. This is going to be advertised to router 1, and router 1 is the route reflector, so it is going to advertise that to router 2. So whenever these two routers want to send a packet to this destination, network 50, they are going to use router 3 as their exit points because this has a better local preference. So let's do this in action. What I'm going to do is to set this route map on router 3. I have removed the weight attribute from router 1. So if I go back to router 1, this is the BGP configuration and you cannot see any route map on router 1. So let's go to router 3. On router 3, I'm going to set local preference using a route map. First of all, I want to create an IP prefix list. IP prefix list, I'm going to name it net50, and for sequence 5 of it, I'm going to permit exact value, because I know that this is the route with this specific network mask advertised into BGP, and I hit enter. This is the IP prefix list. Now I'm going to create a route map. It can be the same name, permit 10, and I'm going to match this using match IP address prefix list net50, and now I'm going to set local preference, and that can be any value more than 100. So I'm going to make it 1000 and hit enter. The rest of the networks, they are not going to have any change. So for the next part of this route map, I'm not going to add any set value. So let's go to router BGP 1. Router 3 is a neighbor to router 1. So it is going to apply this to whatever route that it receives from internet. So no, not router 1, of course, I3. So whatever route that I receive from I3, I'm going to check that, and if it is a match with this route map, it is going to change. It is going to have its local preference changed. So let's go to router 3. On router 3, show IP BGP summary. I can see the list of my neighbors. This is the neighbor that I'm going to apply the route map on that. So I type neighbor 201.33.254. It is going to have a route map, and the route map is inbound. So whatever route it receives, it is going to check it against the route map. So hit enter. Inbound route map. Oh, that's the name of the route map. Net50 inbound. Hit enter. And I'm going to clear IP BGP any softly and hit it. And now I can go to router 1. Check IP BGP. Now you can see this local preference is applied to this route. It has been advertised to router 1. On router 3, if I check IP BGP, it has applied the local preference. And if I go to router 2 and check IP BGP, again I can see this local preference. Now you can see that I have two exit points to reach to this destination. One is directly to I2 and the other is from router 3. And because router 3 is has a higher local preference, it is selected as the best path. And you can see this greater than value at the beginning of this route. Now I'm going to try a trace route to this destination. So if I trace 50 50 50 50 and source it, there is no source here advertised, so I don't believe this works. If I hit enter, no, it works, right? It doesn't work. Yes, it doesn't work because there is no interface, or there is no route on this router that is known to BGP. So what I have done is this. You can see router 3 is used as the exit point to reach to the destination. Now I can do this on router 1, and here, because I have something advertising to BGP, the other side responds, yes, responds. And you can see that router 3 has been used as the exit point and has been used to reach to the destination.